The frame object is one of the most commonly used intelligent object in COMOSYS. The same object is used for modeling steel beams and columns, as well as concrete. It is a very comprehensive object with capabilities that stretch the entire spectrum from analysis to design to detailing. As with all COMOSYS objects, you can double-click it to open the Properties window. As you can see, there are several tabs on top for the various types of properties. Some are section-related, some are analysis-related, others are related to detailing and drawing production. We will go over these one by one to get a clear understanding. The most commonly used tab is the Geometry tab. Here we get to choose the name of the profile from a database, or enter a parametric name directly. If we know the name of the profile in the database, we can just write it directly here and press Apply to see the changes. As you can see, the H, B, S, and T fields are filled by the program automatically. It represents the section height, flange width, web thickness, and flange thickness respectively. If we don't recall the exact name, we can press the section symbol on the side to open the database and choose from a variety of sections. The sections are grouped by section type and families. We will discuss section families in another video. After choosing a section from the database, we can press OK to select it. For steel sections, using profiles from the database is common. But for concrete sections, since the sections can be of arbitrary dimensions, the user can enter certain shapes parametrically. To see the format of these parametric sections, just hover over the section name edit box to see the hint. All parametric sections start with a @ character. For instance, to enter a parametric rectangular section of width 500 and height 800, you are supposed to enter @R500 * 800. On the right side of the section symbol, here is a combo box, which is used to specify whether the section is a normal section, a twin section, or a built-up section. A normal section, as we have already seen, is when the section is composed of a single section. A twin section, on the other hand, is a section in which a particular section is used either twice or 4 times as a single entity. So, for instance, back-to-back angles, cross angles, back-to-back channels, face-to-face channels, etc., all fall in this category. Once we choose the twin type, COMOSYS immediately selects a default back-to-back angle as the profile. As you can see, its name is shown in the name edit box. To fine-tune this twin section, another tab appears on top called the Twin tab. Inside, you can modify the properties of the twin section. For instance, you can change the section or the distance between the back-to-back angles. You could also change it into a back-to-back channel section or a cross-angle section, as per your requirements. The advantage of having the entire twin section as a single object is that The user doesn't have to worry about changing each subpart of the twin section separately like in other programs. The whole section is rotate, moved, copied and edited together. This makes the job of modeling much easier. As a detailer, you might be thinking that lumping both the sections of a twin section under one ID might create problems. For the numbering algorithm as in the detailed model, each subsection of a twin profile might have a different final geometry, because of various cuts etc. This is handled effortless by COMOSYS and each subpart is numbered separately. Finally, there is the built-up option. Built-up profiles are different from twin profiles, in that the subsections of built-up profiles can be different from each other. So for instance, a column composed of an I section and two T sections can be modeled as a built-up section. Other built-up section options like a channel, sitting on an I section both with and without strengthening flange plates etc. are also available. Once again, the whole built-up sections behaves as a single ID, and rotating, moving, copying, giving offsets etc. are handled effortlessly. Below the profile name section, we have the main offsets for in plane and out of plane alignment. The overall rotation is also modified from here. The profile will be offsetted in its local Y and Z directions by using the position in depth and position in plane offsets. Each has 3 different anchoring options, with a further offset if needed. The rotation variable has 4 anchoring options at 0, 90, 180, and 270 degrees, with a further offset if other angles are needed. It's important to note that these anchoring options are available as keyboard shortcuts. The rotation anchor, for instance, can be changed by selecting the profile and pressing Ctrl Q repeatedly until the desired rotation is achieved. Similarly, the position in depth and position in plane anchors can be modified by using Ctrl W and Ctrl E shortcuts repeatedly. Since anchoring the section is one of the most frequently performed tasks in 3D modeling, these shortcuts greatly reduce the task of the modeler. Down below here are 6 more offsets. 3 each for the start and end of the profile. These offsets are extremely useful when just the start or just the end point of the profile needs to be moved, without changing the finite element model. As you know, COMOSYS is not just a detailing package. It is also an extremely powerful finite element analysis and design package. As such, we must have a model which is accurate for both analysis and detailing purposes. Most programs have only one of these 2 options, which creates huge problems when exchanging data. With COMOSYS you will not have any such problems. The integrity of both the finite element model as well as the detailed model is maintained throughout. We will discuss how the user can easily use these offsets for specific situations in a different video. At the moment, let it suffice to say that entering any numbers into these offsets will not affect the finite element model. You can always see where the finite element model is by viewing the model in line mode. Thanks for watching.